like a movie made on a premise alone, not like to be a good movie.
Yeah, it's one of those words that's hard. It's like
Sharknado is like the epitome of schlock.
That's very schlock.
I get it.
It's kind of like, but a lot of times people will use that word kind of endearingly. They'll be like, they'll say it for like Army of Darkness. Army of Darkness is like Bruce Campbell goes back in time and like fights this army of like undead skeletons. It's like really funny. It's a hilarious.
It's like Quest for the I forgot that first half of the title, but Quest for the Holy Grail.
Monty Python.
Yeah.
That's a great movie.
It's got a little bit of that's a little different. That's a bit of a spoof, but
That's like satirical.
yeah. Anyway, so it's
Holy.
okay. So this problem set is all about volume. Okay. So let's just get into it here. So this one says consider a region that's bounded by a parabola. So here's x squared. Here's x equals 2. And then y equals 0. So do we all see the region?
Yep.
Okay. Okay. So what we've done so far in this class is we've just said, what's the area of that region? Okay. So, but now it says, what if there was a 3-dimensional solid whose cross sections were squares perpendicular to the x-axis? I'm just going to give you a moment to thinky-winky about that. What would that shape look like?
Can you say that one more time?
So it's just A is what if this was the base of a solid, the base of a 3-dimensional solid, where every cross section means if you slice it, every cross section is a square. So what do you think that would look like? If this was the base, do you guys know what I mean by base? Like
I see
the base of this water bottle is the bottom. Okay.
It's like if it's the base, it's expanding to be like infinitely expanding outwards, or is there like a
Not infinitely, but like the squares would pop out of the board at you. So
Yeah.
it's like, imagine it, what it's saying is if we sliced it here, and you slice something and then you look at like a loaf of bread, what's a cross section of a loaf of bread? Usually looks something like this, right? That's the cross section of a loaf of bread, right?
Yeah.
So what this is saying is if you slice a cross section, it would be a square.
thin line?
So what would the shape look like over here?
Very
Pointy. Okay. I'm gonna try to draw it for you here in a second, but so imagine, build it up in your mind. Imagine a square popping out of the board here at you. That's a pretty big square, isn't it? In fact, we know the y value here. Who knows what the y value is? This is 2. 4. 2 squared. So let's say I chop this up into a bunch of little squares. The square here would pop out of the board and be a 4x4 square. Pretty big, right? So if I looked at the shape from over at this angle, I would see a 4x4 square. Does that make sense? And then what happens if I sliced it, say, here at 1? That's the point 1, 1. What if I sliced it here? What kind of square would I see? A 1x1 square. How about if I sliced it here where it was really, for example, if I plug in 0.1, the y value is 0.01. So there the cross section would be a little 0.01 by 0.01 square. Do we understand what we're looking at? So that it would actually look kind of like crossbow. Do you see what I'm drawing here? There's that 4x4 square, right? Here, let's say another cross section. Here's that 1x1 square, right?
Okay.
Do you see the little square cross section?
Okay. I understand.
Okay.
So the only thing I'm confused about, why is it 4x4 not 4x2?
That's 4x2 wouldn't be a square.
So the height of it is like the side of the square.
In this particular case. 4 sides,
Yeah.
Yep, to the square. Well, you can look at it from different angles. Let's say you look at it from this angle, like higher up, it might look like here's the square cross sections. You see them?
Yeah.
What, Lillian? My drawing's bad.
No, I was saying that you like definitely like took a drawing class in school where like you draw shapes.
I didn't, but thanks.
That top shape was like really good.
Thanks, bro. Appreciate it.
It seems like it.
You know,
Oh, I'm understanding.
just
now.
elbow grease, guys.
Yeah, it all
It's
clicked.
just elbow grease. Let's see. I can't really draw a ton of.
Physics, yeah.
Here's the thing. From the side, like a total side view would just look like. I mean, it would look kind of like. Well, it actually depends. If you looked at it again, this is the base, so we're kind of looking down on this thing right now. If you look from like underneath, like over here, you probably just see this side of it, like the bottom of it. So anyway, let's get into the calculation. Here's the thing, you don't actually have to visualize the shape to do the calculation. That might be a relief to you. What do I mean? So when they say a cross section, you just have to be precise when you break it up. So you go, okay, a cross section of this is perpendicular to the x-axis. Okay, so let's grab a little cross section, a little slice. All right. Now let's zoom in on that. So I'm going to extract that out and look at it. So okay. Do you see what I did there?
Yes.
How thick is this little tile?
DX.
dx. You feel okay about that? What are the dimensions of this tile? How tall is it, first of all?
It's gonna be 4. It's gonna
This
be-
one would be, but I want a general expression. Would it be
X
dy?
squared minus 0.
X squared minus 0, yeah, which is just x squared, right? Because what I want to do is, this is a dx, so I want all my stuff to be in terms of x, right? So I want to know, in terms of x, how tall is this square? Well, what's the height? It's x squared, right? It's the function. Yeah? And then how wide is it?
X squared.
It's also x squared. That's because the question said it was a square. So then, okay, what's the volume of this tile then? You're gonna make it, Kate, don't worry. You can do it. The volume of this would be,
DX times X squared.
yeah, x squared times dx. So that's the volume of that little disk. Okay, so what you're gonna do is then integrate, because that would actually add up all the tiles. So, and then what's my bounds of integration if I'm going in the x, with respect to x? 0 to 2. So my answer to this would be integral from 0 to 2 of x to the 4th, which is 1/5 x to the 5th, which would be, plug in 2, you get, plug in 0, subtract them. Yeah?
That's the volume.
Yes, that's the volume of that shape. At least if I have one of the square cross sections, what I should have. Oh, this one's pretty good. This one's different, a little different, but it should illustrate the same point. Imagine this shape. What does it look like? Oh, that's savage. I gave away spoiler alert. Imagine this shape, a circle, a circular base where all the cross sections are squares. What does that look like? Circular base where all the cross sections are squares. So there's my circular base. Watch me build it up. Beep, beep. Beep, 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 beep. See the squares? Beep, beep, beep. That's pretty neato burrito, right? No, maybe? Also this. This was made for me. Good extra credit project if you have access to a 3D printer. Circular base, and every cross section is a square. See the shape? See it's because of the limiting, technically it should get really skinny there, but the 3D printer can only do so much. Anyway. Let's move on. How about semicircles perpendicular to the x-axis?
Well, you're gonna do. So when you do pi times 4 squared.
So it's gonna look like this. So same setup, it's the same region. Okay. Now, if you can visualize this, great. That's awesome. If you can imagine a circle, a half circle popping out of the board here, popping out at you.
Oh, that way?
You can go into the board too if you'd like, but this is the base. This region that I've drawn is the base of the object. So if you were imagine this being like a paperweight or an ornament you're putting in your desk, this here is the base.
So
That's what
it's-
would go.
It's gonna go like this.
So the way this would look, I'll try to draw this. So yeah, the board represents like the floor or your desktop, and then this is the base of it, and then these circles would pop out. And so if I draw it from sort of a side angle, it would have, there's that first cross section, try to draw a semicircle, and then those semicircles would get smaller and smaller. So it ended up looking kind of like a horn. Kind of like that, where those are all my circular cross sections. Does that make sense? Okay, hopefully that makes sense. So let's draw a slice. Okay, here's a slice. Hopefully you can visualize that slice. Let's extract that slice out and talk about what it looks like. See what I did there? If you maybe it makes sense to draw it like this, I don't know. Whatever makes sense to you. How about that?
I like that one.
Does that feel better? Okay. Okay, so this, we sure we understand?
Yeah.
So what we ask ourselves is, what's the volume of this cross-sectional slice? How thick is it?
Yeah.
dx. What else do I have to know about it?
It's diameter.
Diameter. And we're going to try to get the area of it, right? This area. So we want to know the radius, right? So what's the radius? Trace of the diameter, which is relevant. What's the diameter? X squared. So the radius is half of x squared. Halfway. So then what's the volume of this slice? Well, fuzzy wuzzy was a bear. The area of this circle is 1/2 of pi r squared. See that? 1/2 of pi r squared times the thickness, which is dx. What's wrong?
Nothing.
Okay.
I'm doing great.
Good. It's good to hear. We all want to do great.
Integrated from 0 to
And then we want to not just get one, we want to get all of them. So you're going to integrate from 0 to 2. So this is the integral. How do we integrate this? Very carefully. What's going to happen to this 1/2? It gets squared, and then he gets multiplied by that 1/2. So it's going to be 1/8. There's also a pi in there, so it's going to be pi over 8 times x to the 4th. By the way, didn't we just do this integral a minute ago? Like, we know the answer to that. So the answer to this is going to be our previous answer multiplied by pi over 8, if you think about it. So anyway, raise this to the 5th power and then divide by 5. Does that make sense, what I just did there?
Yes.
Oh, yes.
Went from 0 to 2. When you plug in 2, you get 32. What's 32 over 40?
4/5.
Yep. 8 goes into both of those. 8 goes in there 4 times and 5 times. So this is the answer to this is just 4/5 of pi, or 4 pi over 4 if you like. 4 pi over 5, sorry. That's pretty neato burrito, right?
I wouldn't, yeah.
Where'd the what? The 40?
What qualifies as neat?
It's a gut.
I can't define it, but I know it when I see it.
Oh my.
Okay. You're the one who told me who I thought it was like Roberts, and you told me it was someone else, right?
I don't know.
Or maybe I thought it was Clarence Thomas, and it was actually Robert. Okay, I can't remember. Or maybe I thought it was Scalia, and it was someone else. Anyway.
Justice Scalia. He died in a car crash. Didn't
I thought he just died of like oldness.
he? I thought he died in a car crash. I remember all this happening.
Scalia? I can't remember. Okay. Do we feel okay about that?
Okay enough.
C. Rectangles with a height of 3 perpendicular to the x-axis.
So what is that? Oh, just because
Take
it's.
them. I'm gonna erase here. See if you can visualize it. Unfortunately, the reality is visualizing these for some people is very challenging. For other people, it comes more naturally. I don't know why that is. We live in a society. Do you agree or disagree?
So true. So true.
So profound. We live in a society. Okay, so what's the thing about these rectangles? They're all perpendicular to the x-axis, and they all have a height of 3. So they're all going to poke out of the board the same amount.
Yeah, we know the things.
So what shape is that?
It's just that.
Yeah. Is this gonna be like that graph?
But
Huh?
3 times 3.
It would be, yeah, exactly. The answer would just be, this area multiplied by 3. But it's like a ramp, like a skateboard ramp, kind of. Because you wouldn't want a skateboard ramp, if you're approaching a skateboard ramp, you don't really want it to look like this, like that first one, do you?
No.
That'd be tough. This one's different from if you looked at it from this angle, it would look like this. Well, I'll draw it slightly from the side. You see what I'm talking about?
Yeah.
Yeah. There's the base, this right here. Right?
3.
So to make it go from here to here, I have to kind of rotate it like, whoop. Does that make sense?
Yes.
Yeah.
So anyway, so again, I look at a slice, look at my slice here. This rectangular slice poking out of the board, right, has a height of 3. So that's 3. That's always 3. And how big is that?
That's good.
That's x squared. How thick is it?
Yeah.
Dx. So the volume, this one's a bit easier, is just same bounds of 3x squared dx. That's an easy one, right? What's the answer end up being for this? Eight. 8. Right?
Yeah.
Are we confused or do we feel good? We are? Question? What's your question?
I'm sometimes confused on B, like how I have to multiply it by the 1/5 x.
Multiply it by, well, so on the last one we had, so you understood how we had the pi over 8?
Yeah.
And you understood, so this all, so. So you were okay getting to this part? That's good. So raise that up to 1, raise that up 1 bigger. So now it's x to the 5th, right? So then you have to divide by 5.
Yeah.
If you divide this by 5, that's the same as multiplying by 1/5. And 5 times 8 is 40. That's where the 40 came from. That makes sense?
Yeah, that makes sense. I was thinking that we did integrate the pi over 8.
Yeah, we could have also just moved, that's just a number, so we could have moved it outside the integral. That's our other option.
So Mr. Hall, on this one, I was confused, and I still am, but with a height of 3, we find the area for the whole thing, it's not like a limit, like when it says height of 3.
What?
Okay. I'm trying to figure out. Because the question just says rectangles with a height of 3 perpendicular to the x-axis. So, okay, yeah.
So the height is this.
Yeah.
So that my marker is, let's say this marker was a height of 3, and every rectangle, no matter where, these rectangles are really skinny, but a height of 3. These rectangles are kind of wide, the same height of 3.
I got you.
Okay, and then how about rectangles perpendicular to the x-axis whose heights are twice as great as their bases? I could just be lazy and just modify this picture. Heights aren't 3 anymore, are they?
They're 2x.
The heights would be 2x squared, because it says the height, for any given rectangular tile, the height is double as big as the base. Does that make sense? We sure understand that? The word base is getting used twice here in 2 different ways. That can be a little based. Yeah, based. Try to be based. But that is confusing. Because this is the base of the solid, but then this is the base of the rectangular cross section. We're sure there's no confusion? Okay. All right. Fair enough. TikTok meme, remember that one when they said fair enough? That was so epic.
Fair enough.
That one guy, he'd say fair enough.
I'm
He'd
a
say
little lost, but
fair enough. Ah, such a good meme. Okay, so this is
We
going to
actually
be.
made a TikTok about that for your class.
2x.
Oh, it's so savage.
Right?
Did you own me with facts and logic?
Yeah.
That's lit. Okay. Do we understand going from here to here?
Yes.
Yes.
Yes. It's understood.
So this one turns out maybe it surprises you, maybe it doesn't. I hope it doesn't surprise you too much. The answer is going to end up being just twice as big as the square one, right? Because of the cross sections are just twice as tall this time.
60.
So you should get
64.
64 fifths.
What I get
Square one.
2.
Huh?
Oh, wow.
Just get a little mouth on, Trenton.
Okay.
It's just a prank,
I'll
bro.
just write it. I'll just write it
It's just
right.
for TikTok.
64
Oh,
fifths, you
because
said?
I thought,
64 fifths?
because I thought 16 times 2 is 36, but that is not the case.
Right, but squares are rectangles. These, do you see how, look back at the square one. The square one was x squared by x squared. This one's x squared by 2x squared. So every little slice is exactly twice as big as the squares. Right, fellow society members?
Indubitably.
Are you functional?
Indubitably. That's a good word.
What does that even mean?
Undoubtedly.
No doubt, bro.
So,
Unequivocally.
what's the one word that, inconceivable from Princess Bride?
Inconceivable. That's a good movie.
Then he
Do you deserve it?
Then he gets absolutely blown. Like Max and Logic and dies.
He didn't have enough elbow grease. He should have had a side hustle.
Oh, it wasn't working hard enough.
Okay. Equilateral triangles. Okay, so first, I actually have one with some, it's a square root function, but it's the same principle. I made one where, here's one. There's a little square root function, and all the cross sections are gonna be equilateral triangles. So there's kind of hopefully this view looks good. So let's make the triangles. You see?
That is so cool.
And then you can look at it. But you see what I mean by, hopefully this maybe clarifies what a cross section is, if it's still not, it's still confusing to you, but as you can see, if I slice this thing right here, there's my triangular cross section. So
It's like aloe vera.
aloe vera. So let's draw the picture. This guy is going to, this is one way you might draw it. This might make the best sense to you, I'm not sure.
Well, first off, I'm not gonna do that.
I could draw it like that, kind of poking out of the board, or I could draw it into the board like this, if you like that better. How about that?
Like that.
Yeah.
Either one, right? Or, do we understand?
Yes.
Okay, now. How big is this?
That's X squared.
X squared. How thick?
Yes.
Now, does anyone? Someone's gotta have a thought, right?
1/4 X to the square. Nope. 1/4 X to the fourth.
Oh,
Is it one half?
I wasn't really, I don't think anyone, I'm not expecting you guys to have this one memorized, but at least be like, we need to have some way of going from the side length of an equilateral triangle to its area. I guess that's all I was trying to get at. It's like,
1/4.
so there is a, this is what it look, I'll derive the formula for you, ready? Okay, here's an equilateral triangle.
That is.
It's L by L by L, right?
Oh, yeah.
Oh, wait.
So what I could do is chop this, there's the height that I want, right? There's the height. Yeah, what kind of triangle is this on the left then?
36.
The right.
30, 60, 90, right? Because this is 60.
No.
And this is 30, yes? Because an equilateral triangle is 60, 60, 60, right? It's perfectly symmetrical. We sure? Okay.
Yes.
So then, okay, then how big is this?
One half.
That's half.
So it's going to be.
And then how do you go from, we're going way back to ninth grade here. The short leg is half as big as the hypotenuse,
God.
and the long leg is
Root 3 times bigger.
yes, root 3 times bigger than this.
Root 3 times 1/2 X squared.
You understand?
I refuse to believe it's root 3, but okay.
We can prove it with the Pythagorean theorem if you really want to. This is a pretty basic result. Okay, comes up a lot.
Dude, I actually remember this.
Okay, so then what's the area of this triangle then? Remember, the goal was how do I express the entire area in terms of one side length?
So
So this says
1/2 X squared
It would
times.
be just L root 3, right?
let's just really jumping the gun here. Okay.
Those are sharp.
1/2. Here's the base, right? 1/2. What's the base? L. What's the height? L times root 3 over 2, right? Do we understand?
Yes.
Mhm.
So it turns out the formula is not an obvious formula at all. It's a quarter of root 3 times the side length squared. Do we understand?
Yes.
What, Kate? You laughing at me for tripping over my chair? This is a safe space for me. I got owned by chair. Okay. So then the area of this tile would be root 3 over 4. You still with me here?
Mhm.
Times that squared, right? Times dx, the thickness. Yes?
Yeah.
Yes, sir.
So how is this volume going to differ from the square volume?
I don't know. Let's find out.
By a factor of root 3 over 4.
So let's just multiply the.
Right?
Now, yeah.
Okay, because we know we've done this point a lot of times, right? We've done the integral of x to the 4th.
It's 32.
So it's 32 fifths. So the answer to this one's just going to be 32/5 multiplied by this factor. Do we understand that or no?
Yes.
Yes.
So 4 goes into 32 8 times. So the answer to this is an interesting number. 8√3/5.
That's like really cool.
Is that a strange number?
They're all very pleasant
Society.
numbers, just looking at.
Well, yeah, the first 3 primes are 2, 3, and 5. This is 2 cubed. 2 cubed times. Kind of interesting. We destroyed by facts. Facts.
Facts, bro.
Facts, logic, and
No
prime
cap.
factorizations.
Oh, now I've got white.
No cap. Wait, do we understand? If you're not comfortable with that, I mean, you should be comfortable with that idea. But if you want to just do it like as if this is the first time you saw it, then it's fine. You raise it to the raise it to the 5th power, right? And then divide by 5. So this is a 20 now. And then when you plug in the 2 and the 0, 32/20 is 8/5. Yes.
Mhm.
Really killing you guys, aren't I?
Yep.
No.
We're born to suffer, right, Trey? Okay, we live in a society. F. The most respectful question on here. Haha, memes.
We do be living in.
Press blue button to doubt. Haha.
Wait a minute.
That would actually be George. That would be kind of funny to see. What? We do live in society.
Maybe
We live in a society.
Okay, this one's a little bit more interesting. If you found it too easy, then you'll like this one then. Okay, what were these two x? So this is the x value of 2, y value of 4, right?
Yeah.
For f, we're asking, what about squares perpendicular to the y-axis? Well, let's draw that. What does that look like? Do you understand how it's going to be the same overall shape, but it's not necessarily the same dimensions? Because now you can imagine a square popping out. What are the dimensions of this square on the bottom?
Oh,
It's 2 by 2, right? So can you visualize it popping out of the board?
Yep.
And then down here, they're really skinny. So let's draw one of those. Okay. How thick? dy this time. Dy. Okay. Now, what does that tell me? That tells me everything in my integral has to be y value, like y's. Which ultimately, if you think about it, are actually x values on the picture. Because like how wide is this tile here? It's this point's x value minus this point's x value. So what's this point's x value? 2. What's this point's x value? The square root of y.
Yeah.
How do we feel about that? How are our feelings? So the reason I know that is because, remember, I hope this is clicked for you, that if you, once you recognize that I got to be doing my integral in terms of y's, any curve I have written like this, I need to rearrange. Okay? So when I say, what's this point's x value? Well, this line is x equals 2. What's this point's x value? Well, my x value is the square root of y. So that's where my 2 minus y is coming from. Are we sure we understand that?
Yes.
There's no questions? It's tricky. It's not easy.
I'm pretty sure I got it.
Okay.
I'm getting it today, but I'm gonna need an explanation on this.
Probably.
What if they just banned Caleb from the school? How do you even, can you do that?
Can you ban all gender?
Let's
She has a redhead. She's not
I don't want to lose.
Okay.
Stop it.
So the volume of this tile then would be, it's a square tile, right? So it's going to be 2 minus root y squared. multiplied by the thickness. Do we understand that? We all understand where the square's coming from?
No, where is that coming from?
Because this tile is a square.
Okay.
So the area of this thing that I just shaded is 2 minus root y multiplied by 2 minus root y.
Oh, okay.
Just write that as 2 minus root y squared. And then last tricky question here, what's the bounds of integration?
0.
0 to 4.
Oh.
Okay. Last one. This is gonna be a little bit tricky, just trickier to set up, but semicircles.
Wait, yeah.
Well, it's 1/4.
I guess the question just says write an integral.
Wait.
How have we been solving them all?
It's good.
For the memes,
Okay.
for TikTok.
I'm gonna keep them both on.
You never heard of TikTok? That's where the
No.
renegade comes from.
Charlie DeMillo.
Have you not heard of
She's
TikTok?
failing all her classes apparently.
I thought she got canceled.
She's
She's like 15,
16.
yeah,
I
she's
thought she
my
did like all this one.
Yeah,
Like,
she's-
Yeah,
yeah,
everybody
that's
did
cool.
that.
I really don't like the TikToks.
Man, she really needs to graduate high school. She needs to find, she really is gonna have to find a job and stuff.
Yeah.
Make sure you get those signature Charlie D'Amelio caramel mocha frate lattes of Dunkin' Donuts. They pay me to say that, so. Not as much as Charlie D'Amelio.
Capital T,
They
they.
pay me a little bit, yeah, Dunkin' Donuts. Okay. Semicircles, last one of the day, semicircles. Same setup pretty much, right? Still same kind of slice, but this time, I think last time you guys said you liked it better if it was drawn more like that. Okay. What is the radius of that disc? Of that semi-disc, really, it's a half disc.
Well, they just made one.
1/2 of this, right?
Yeah.
So when he was a square, that's the quantity I wanted, but since I just want the radius is half of that amount. Okay? Do we understand that?
Yes.
So then what's we know the thickness is dy. What's the area of that semicircle? 1/2 pi r squared. Do we like that? Let's clean that up a little bit, because what can I do with this 2?
Just remove it and leave it there.
Yeah. You could. I mean,
Break it
there's
apart.
there's actually a strong argument to be made for, like, if you're just writing the integral and you write it like this, 1/2 pi r squared dy from 0 to 4. This actually embeds a lot of information in a very obvious way. You can read this and go, oh yeah, this is the radius, 1/2 pi r squared. Whereas what I was getting at, I guess, was if you simplified it, this 2 would get squared, make a 4th, you can pull it out over here and have a pi over 8. The point of this one would be, what does this do for you? Well, suppose you knew this answer. This would tell you that this answer just differs from the square answer by a factor of
Did you just say that?
pi over 8. Yeah, so the 2 squared is 1/4, right? And pull the 1/4 out to be with that 1/2. You got what I'm talking about with the factor? So it makes it so you don't have to, it reduces the problem to one similar to one previously solved. So if you knew the answer to this, then when you manipulate this one algebraically, you see, oh, I just multiply my previous answer by pi over 8. Have a good weekend.
You too, Mr. Hall.
Oh, is this half my day?